There we go. So if we're taking a look at this, the sum of the subscripts in the electron configuration represents the total number of neutrons, it says. Have we been talking about neutrons? What subatomic particle have we been talking about? Electrons. This is false. That should be electrons. The Aufbau principle states that electrons will fill the orbitals from the lowest to highest energy. That is true. Electrons fill from lowest to highest energy. An electron configuration uses boxes and arrows to show where electrons are located. This is an electron configuration. Are there any boxes or arrows there? No. They are talking about a box or orbital diagram. That is false. According to Hundrel, when electrons are filling the 3 orbitals in a p sublevel, 1 electron will enter each orbital singly before pairing up with another electron. This is true. We said that whenever you're filling up the seats at a booth, you don't usually both people sit on the same side before one gets one each. That is Hundrel. Electrons in 4s have more energy than those in 3d. This, if we recall, 4s has less energy than 3d because 4s fills in first. So that should be less. The abbreviated electron configuration for chromium is argon 4s2 4d4. Argon 4s2 4d1 2 3 4. This is true. How many electrons does iron have? Yeah, question? For which one? The chromium. Argon 4s2 1 2 3 4. I'm sorry, it should be 3d4, shouldn't it? This is 3d4. I couldn't see. I need new glasses. False. Let's try that one more time though. Argon 4s2 3d1 2 3 4. 3d4 chromium. So what I should put here is false. Argon 4s2 3d4. How many electrons does iron have? How many electrons does iron have? Anybody at home playing along? How many electrons does iron have? How many electrons does hydrogen have? 1. So how many electrons does iron have? What's the atomic symbol for iron? Fe, and it has 26 electrons. What if it's iron 2 plus? Does the +2 mean it's gained or lost electrons? Lost electrons. How many did it lose if it has 2 pluses? 2. So if it had 26, then that means it now has 24, right? Here's a box diagram for magnesium and phosphorus. Let's do the one for argon. I'm going to do the one for argon right over here. We have 1s, we have 2s, we have 2p, we have 3s, we have 3p. That'll be enough. So argon has 18. If you're not knowing how we're getting these, you just have to look. Right there's argon, there's the 18, that's the atomic number, that's the number of protons and number of electrons. 18. So we have 1, 2, 3, 4, 5, 6, 7. Remember, when we do that, we have each one getting one. That's that 100 rule. 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Notice this makes sense because argon is a noble gas and its electron configuration is completely full. So that makes perfect sense. Write the complete electron configuration for an element with an atomic number of 11. So 11 is here. So we have 1s2, 2s2, 2p6, 3s1 for 11. 1s2, 2s2, 2p6, 3s1, 3s1. Write the complete electron configuration for cobalt. Cobalt is 27. So we have 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. And remember, we get down to 3D. We want cobalt 2, 4, 6, 7. 3d7 for cobalt. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d7. Cool. Then it says write the abbreviated electron configuration. So zinc is here. We go back to the previous noble gas, which is argon. Argon, where's my whiteout? There we go. Get rid of this 1.5 right here. Never happened. Argon. Argon, right after argon is 4s2. What do we want? Zinc. 4s2, 3d10. 4s2, 3. That's not how you make a 3. 3d10. Barium. Barium's all the way down here. So we go right before it, and then is xenon. And then 6s2. 6s2. Good. Identify the elements with the following configuration. So to do these, we add up. 2 plus 2 is 4, plus 6 is 10, plus 2 plus 2 is 14. That has 14 electrons. That's silicon. 2 plus 2 is 4, plus 6 is 10, plus 2 plus 6 plus 2 is 20, plus 10 is 30. And this should be an uppercase 5. That is, let's see one more time. 10, 20, 35. Who is 35? 35 is bromine. Xenon. Xenon is 54. 56. 56 plus 10 is 66. Plus 4 is 70. Plus 8. 78 is platinum. And, yep. 78 platinum. Cool. How many sublevels are in the fourth principal energy level? Well, you have S, P, D, and F. You have 4. How many lists of sublevels that are in the second? You have S and P. Remember, the number of sublevels is equal to the principal energy level. The PEL equals the number of sublevels. How many orbitals are in 5P? Well, P has 3 orbitals. We have 1 orbital, 3 orbitals, 5 orbitals, 7 orbitals. Right? So how many orbitals are in the 6D sublevel? Well, 6D has 5 orbitals. What element has only 3 electrons in its 3p? So we want to see 3p. We're going to see 1, 2, 3 electrons. So 3p, 3. Here is 3p, 3p1, 3p2, 3p3. That is phosphorus. What element is the first to completely fill up the third energy level? That would be 3d10. 3d10 is zinc. 3d10 is zinc. What is the highest level used by a cesium atom? We need to find cesium. The highest level used is 6. 6s is the highest level used. What's the highest energy level used by a silver atom? Silver atom, that would be 4d. 4d. 4d is the highest sublevel or energy level. It actually has a 5s though, but that's not higher in energy. The 5s is not higher than the 4d in energy. What element is the first to have a full second energy level? Well, that's going to be the noble gas, neon. 1s2, 2s2, 2p6. That would be neon. What element has the first full 4p? So remember, the p's are always one behind. 2, 3, 4. The first one to fill that up is krypton. The element is first to use a D sublevel. Right after 4s comes the 3d. So that is scandium. How many unpaired electrons are in the sulfur atom? So if we take a look, we want to look at the final thing for sulfur, which is 3p. One, two, three, 4. How many are not paired up? 2. Remember, sulfur is in 3p. 1, 2, 3, 4. 2 are not paired up. What element has the last electron at 6p2? Here is 6p, 6p1, 6p2. So that is lead. How many electrons can occupy an s sublevel? 2s sublevel? S can only hold 2 electrons. How many electrons can occupy a d orbital? This is a d sublevel. D sublevel. This is a d orbital. Only one of those boxes is an orbital. So again, each orbital can only hold 2 at max. How many orbitals are in the 7p? Well, just like the 3p, there are 3 at 7p. The 7 just tells you that those orbitals are further from the nucleus. How many sublevels are in the first, second, and third energy levels combined? Well, we have 1 there, we have 2 there, we have 3 there. We have S, SP, SP, D. So that's a total of 1, 2, 3, 4, 5, 6. 6 sublevels. 6 sublevels. Good, good. Questions there? All right. So that quiz is Wednesday. If you have questions on that for Wednesday, make sure you come in and then go take the quiz. Today, I just want to make sure that we understand algebra a little bit. So let's take a look at these things up here. So if we take a look, we have energy of the photon equals HF. And energy of the photon equals HC over lambda. So let's talk about those waves that we started talking about at the beginning of class. The distance from here to here is a lambda, or what we call the wavelength. The number of waves that occur per second 1, 2.5, 2.5. That's known as the frequency. And the unit for frequency is hertz. You've heard them talk about hertz before. Whenever you talk about an amplifier, right? That changes what we call the amplitude. That's what can make waves louder for sound, right? Louder for sound. We amplify the sound. But basically, it makes their higher up, their wave height higher. Yes? So the what? The what? No, but that can tell us like the light that gives off by the element. The higher they're up, the more electrons they have, so the more lines that they would have the ability to have. Now, we looked at electrons becoming excited and then giving off energy in two ways. We looked at it by exciting them with electricity, and we looked at it by exciting them with fire. So when those electrons drop back down, they release a photon. You have an electron around the nucleus. It gets excited when it gains energy. And it may bounce up further away from the nucleus. But it bounces back down when it emits a photon. And that photon is in the form of a wave. To calculate the energy of that photon, you can either know the frequency or the wavelength, and then you can calculate the energy. A man by the name of Maxwell Planck came up with this, and that's what's known as Maxwell-Planck's constant. This C right here, that is the speed of light. Light in a vacuum travels 3.00 times 10 to the 8th meters every second. So C is actually used to denote the speed of light in an equation. If you remember the equation E equals mc squared, C in that equation is also the speed of light. So we want to calculate the energy of the photon, and we are given the frequency. So which of these equations allows us to use frequency to calculate the speed, the energy of the photon? Let's call them equation 1, 2, and 3. 1, 2, or 3. You can type it in the chat. Which one allows us to find the energy of the photon given the frequency? One, two, or 3. Whew. Anyone at home? Ka, what do you think? 1, 2, or 3? 3. So 3 has energy of the photon, H, C, and lambda. We have frequency, so 3 will not work. The first one has H and F and energy of the photon. So to find the energy of the photon, we just need to take H times F. Planck's constant is 6.626 times 10 to the negative 34th joules seconds. We're going to multiply that by the frequency, which is in hertz, which is 1.55 times 10 to the 19 over seconds. That's what seconds to the negative first means. So what's going to happen here is seconds will cancel out and we will be left with joules. I'm going to plug that into the calculator and make sure everybody remembers how to use that. 6.626 times 10 to the negative 34th times 1.55 times 10 to the 19. It's going to give us 1.02 or 1.03 times 10 to the negative 14th. Joules. 1.03 times 10 to the negative 14th joules. Which equation are we going to use for number 2? The second one has lambda in there, but we're still trying to find the energy of the photon. So we could use lambda to find frequency and then use the first one, but there is one that's easier. And that is number 3. The energy of the photon equals h times c over lambda. So all you've got to do is plug that in, plug the speed of light in, and plug Planck's constant in. That will be homework for Thursday. Last thing we're going to do today is pretty easy. A man by the name of Niels Bohr. Niels Bohr basically created what's called the Bohr equation. And the Bohr equation allows you to find the energy, just like we did here, the energy of the photon, but it allows you to find the energy of electrons in a particular level. So the hydrogen electron's energy depends on the location outside the nucleus. The further away, the higher the energy. So Niels Bohr derived this equation based on the energy level. So the energy of the electron in the first level is called E sub 1. Second level is called E sub 2. Notice that the energy calculated is a negative value and it is labeled in joules. So when we take the negative 2.18 times 10 to the negative 18th joules, and we're going to divide that by the 1 square. Well, 1 square is 1. So we get negative 2.18 times 10 to the negative 18th joules. So then we're going to do that for the second energy level. Two square is 4. So we're going to take negative 2.18 E negative 18, and then we're going to divide that by 2 squared. We get negative 5.467 or negative 5.47 times 10 to the negative 19 joules. And I'd like for you to do that for 3, 4, and 5 for Thursday of next week. Remember, Wednesday we'll come in here, review quickly, and then take the quiz. And Thursday we'll come in and finish this up. So I'm going to give you the rest of the period today to get this problem done and this problem done, so you'll have it for next Thursday. If you have any questions, by all means, stick around in the Zoom. Otherwise, have a great 4-day weekend. You guys got any questions in the class? Yeah. Yeah. What's the other question? Another orbital thing? Yep.